produce carbon-14 changes, also affect global temperature measured by oxygen 18. Don't forget, we didn't have thermometers thousands of years ago. This is a period of over 3,000 years with detailed correlation. I will move a little faster now.
Excuse me, Brett. Can you explain what the solar activity is that's having an effect?
Yes. The sun does a variety of things. It puts out radiation in the visible, which of course has been measured now for a very long time. But since the beginning of the space age, we've been able to measure also the emission in the ultraviolet and in X-rays and other regions that do not penetrate to the surface of the Earth. One of the important emissions from the sun is in terms of particles. The sun emits bursts of particles called the solar wind. And these particles in turn, the solar wind in turn, carries magnetic fields. And these magnetic fields carried by the solar wind affect the trajectories of cosmic rays. It gets very complicated now. Cosmic rays then change in accordance with solar activity, and it's the cosmic rays that actually generate carbon-14 in the Earth's upper atmosphere. If you ever wondered where carbon-14 comes from, the only source we know of is cosmic rays entering the Earth's atmosphere, smashing into nitrogen nuclei, and generating carbon-14. That is the source of carbon-14, and as you all know, carbon-14 is radioactive. It decays in about 5,000 years, so it's constantly reproduced, and it's measured in tree rings, so we know exactly how much carbon-14 is produced each year, and we can therefore establish the intensity of cosmic rays going way, way, way back, thousands of years, from tree rings, and also from stalagmites. Okay, I'm going on to the next topic now. Temperature. Temperature measurements are very difficult and very uncertain. The only ones that I believe in are satellites. These are satellite temperature measurements. Satellites, unfortunately, have only been able to measure temperature since 1979, so that's exactly 30 years. We don't have satellite data going back further than that. Take a look at this, at the global data from satellites. And ask yourself, what is the trend of temperature? And you immediately see that there's uncertainty. Look, one way to establish trend is to draw a straight line from the beginning to the end, like this. And you say that, yes, the climate has warmed in the last 30 years. Okay. Another way to proceed is to say, well, let's look at the record between the beginning of 1979 to about 1997. During that time, there has been hardly any change, zero. Then there was a sudden increase, a jump, and now we're in a new regime, and you see in the last few years, no increase. So really you can say that there's zero change, then a jump, and again zero trend. Which is it? The answer is it's optional. Unfortunately, one cannot uniquely define a trend. One has to always specify the beginning and the end. One has to specify the time interval. It's like establishing a trend in the stock market. Depends on the dates of when you start, when you stop. So economists know all this stuff. Atmospheric physicists are just learning. So one cannot really speak of a trend. Let me show you something else. This is the global temperature record. You see it of surface data. This comes from a magazine called Physics Today. And look at the blue curve here. Or is it green? I don't know. Let's say it's blue. It seems to indicate that there has been an upward trend. Can you yeah. It's fictitious. Why? What the authors have done is to do smoothing. They smooth. They averaged over a number of years. And since we have this huge, humongous temperature increase in 1998, it affects all of these averages. If you did not pay any attention, you could see that there has been no change in temperature over these years, a sudden jump, and then again, no change. So you have to be very careful.
Dr. Singer, we
Yes.
have about 20 minutes left, so I would like to have some discussion. So I wonder
So
how
I will
much more.
quickly go to do sea level, because that's the important thing. Skip over CO2, there's time about climate changes, sea level rise. Sea level has risen 400 feet in the last 18,000 years. These are data from corals. These are good data. Everyone believes that. What I want you to see is that sea level has been rising in the last few thousand years. See, that's. Can you read this? I think it says.
It's like zeros at the left.
I think it's 5,000.
It's 4, 8, 12, 16.
Yeah, it's 20,000 years.
4, 8, 12, 16.
4,000, yeah. Sea level has been rising slowly at a constant rate. These are estimates from the IPCC. In 1990, they estimated this much sea level rise, 360 centimeters. In the next report, it has shrunk. In the next report, it shrunk again. So you see, they've been estimating sea level rise, but less and less every time they made a new report. Finally, these are the current estimates. This is by Hansen. Maybe you've heard his name, of NASA. 600 centimeters, that's what Al Gore uses. That's me down here. Yes. So we have big differences about future sea level rise to the year 2100. I am of the opinion sea level rise will continue at 18 centimeters per century. No matter what we do, nothing we can do about it. It's like the tides. It will continue irrespective of our actions. I want to remind you again, as I finish my discussion, that temperatures have been cooling for the last 10 years, that the best forecast is for continued cooling, in spite of the fact that greenhouse gases keep on increasing. That's what we're looking forward to. Thank you.
Okay, so the students requested to field the first question. So can we have a couple of students asking some questions there? Go ahead.
Yeah, I was wondering if the NPCC
Ah.
fusion.
Can you turn on the microphone?
Oh.
So we'll need to repeat the question also.
Just press it once. Yeah, that's good.
Okay, So I was wondering, does the NPCC, do you do any independent research, or are you just data miners?
What was the question?
The NIPCC, the group that you're part of, do they do some independent research or just
No.
data mining?
No independent research, simply, like the IPCC, we summarize available data in the published literature.
Yeah, it just seems that you have a lot of critiques of the published data, so why aren't you doing your own research?
She said, since you have mostly, he has hearing problems. Since you have mostly critiques of the published data, why don't your group publish and do your research and publish your own data?
We don't publish our own data. We use the data that are published. We publish our own data, we would be accused of manufacturing information. So we use what's published. We just interpret it differently. We show that the interpretation given by the IPCC is not correct.
Thank you.
In other words, we show that there's disagreement. For example, in the fingerprints, we simply use their published model result and their published observations. These are the two fingerprints, and we compare them. We show they do not agree.
Somebody else? Any other student? Go ahead. Yeah, first once the light goes on.
Do you feel that there are other reasons that as a global community we should try to reduce our CO2 emissions other than if it's contributing to climate change?
Your brother?
Yes, in addition to greenhouse gases, the important factors affecting climate are aerosols, which are created by human activities. They generally produce a cooling effect, according to the IPCC, and we agree. I can go back and show you. Slide.
Yeah. Yeah, what he's asking is, are there any other reasons that you think we should be reducing CO2 besides warming? Are there any other reasons?
Oh, I see. No, CO2, carbon dioxide, as you know, is non-toxic, non-irritating, a natural component of the atmosphere. It's in our bodies, in our lungs. We breathe out carbon dioxide. But most important, it is plant food. That's what plants live on. Plants process carbon dioxide to generate plant material using solar energy. Photosynthesis is essentially the processing of CO2 into carbohydrates, or hydrocarbons, if you like.
Yeah, go ahead.
You were saying that the IPCC was biased by their hypothesis going into creating a report about the climate change. What steps did the NIPCC take to prevent having bias from your own hypotheses into your report?
So since your argument is that the IPCC is biased in their reports, what steps do you take to guarantee that the NIPCC is not biased in their reports too?
That's a good question. It's very hard to do. All we can do is publish our results, our analysis, using the same data. But the IPCC doesn't show that there is disagreement. And then leave it up to the reader to decide. We probably are biased. But there's nothing wrong with that. You have to have, you have to have some hypothesis to start with. Our general hypothesis is that perhaps natural forcing is more important than human activities. And we find that the evidence supports that. And we also find that the evidence does not support the IPCC. Their conclusion is opposite to ours.